Okay, in this video, I'm going to pick out and spend some time with some examples. I will suggest that you read through the notes in the initial slide. Matthew gives you a couple of ways that you can define lists from ranges. You can have the first value with 2 dots and then the last value, which specifies a range. So if you put this in, essentially it understands that with a single value step 5, 6, 7, 8, 9, for example, you can specify with the starting value, it will also change the way that the step works. But there's a really interesting thing that if you put the first value and you put the second value and then you put a last value, you get the first and the last of the list, but this defines the step. So it will go up in steps of 2. That's quite a clever feature. By having the second term before the 2 dots here, it then means that you have a step 2 as you go through, and you can do different variations. So this is something that's worth playing around with. What I'd like to focus on is something called list comprehension. Now, this might be quite a tricky concept to sort of get clear, especially when you're used to manipulating and working with lists in languages like Java, where you have to provide mechanisms. That's the important thing here. Here, with a functional program, you don't have to provide a how to go through a loop, a mechanism to actually execute an evaluation of a certain kind of procedure. What it allows you to do with a functional program is simply define what you want to do. So we're going to look at some examples and work out through these concrete examples and talk them through. Let's start with me just playing with stuff. Okay, so let's just simply define a list. Okay, and give it some values for our initial example, and now we're going to use these square brackets. So when you create a square bracket, you enter this thing called a list comprehension. The first part here defines the statement to evaluate against an item. So if I lift an item out from here, now this is not an index, this term item. It is not an index. I'm not going through this in index. I'm literally lifting out each item. Then I'm saying the items all come from or belong to that list. Now, if I just type that in with the guard separating out these two parts, look at what is evaluated, 2, 4, 6, 8, 10. So what I'm saying is that I'm taking each item, multiplying it by 2 to generate this new list. And the items are members of the list. So this notation for the second bit defines the source out of which this list comprehension will work. That's it being evaluated. Notice, I didn't have to build a loop. I didn't have to spell out how I want this to happen. I simply said, that's what I want to do, and that's where it's coming from. Let's work through some other examples. Let's try a different list here. We'll create a separate list. And we'll just put more values in here. So for this one, we're going to use a slightly jumbled up sequence of numbers to illustrate a couple of other relationships. In this list comprehension, what I'd like to do is work out the modulus, evaluate the modulus of each item from a list against 2, and if it equals 0, that's what I want to evaluate. So, i.e. there is no remainder, it divides by 2. The guard simply tells me that the items will come from the second list. I can spell that correctly. Now what you notice, let's make some space so you can just see how this evaluates and how it works. Remember, we are not giving mechanisms. It is saying, taking the items from the B list, no other condition, working out the modulus. When it equals 0, I will return it into here. So it's true for 2. clearly, yes, that's modulo 0. That's not divisible by 2. There's a remainder of 1. That's divisible. That's true. That's false. That's true. That's false. And that's what you see evaluated over here. So it starts giving you a picture of how clever and condensed these evaluative statements can be and what they can do. Let's add what we call a test to the end of this part of the statement. Let's say you want to restrict all the items. The only items you're interested in are those that are less than 5. So now we've got true, false, true. So it has picked 2, 3, and 4. They're the only three values that satisfy these two conditions. They come from the list, and the item value is less than 5. There's only 2, 3, and 4, which is true, false because it's 3, and true because it's 4. So you start getting an idea, and we can do the same thing here. If we copy this, let's do it from our A list, but not a modular statement. Let's use this one up here. Let's alter that. Let's say that we're only interested in items less than 5. And you notice that if we look up here, probably better if we make it less than 3, so you can, right? So we're only interested in 1, 2, then we get to 3, so that's not included, that's not included, that's not included. So all I'm seeing is 1, which is square, which is multiplied by 2, and 2, so it's 2 and 4. So you can see how you can sharpen up your conditions for your operation. And again, we're not giving it mechanisms, we're defining what we want and the conditions of the evaluation, the source list, and some further condition on the items in that particular list. Let's continue and start looking at some more complexity. I'm going to write out a function over here and talk through what's going on here and see if you can work it out. There's my list, which is going to function as my first parameter, and I am going to return, as you can see from the notation, an integer list. Now this one, I'm going to hold inside here a tuple of integers. We've got already quite a complex little statement. All we've done is varied and extended the concepts we've had so far. Get rid of this so it doesn't complicate our screen a bit. Let's just be clear. We've got a list made up of tuples, int tuples. We haven't specified a length, we've just defined the pattern of that list. And the return or result is a list of single integers. Now have a look at the actual function definition. Let's just call my parameter list. And that parameter, which is essentially my list, is going to pass into this list comprehension statement. So if you remember, the list comprehension statement will have some calculation or evaluation, and the evaluation is going to be I plus j. Okay? At this stage you don't quite know what I and j are, but I and j as a tuple, the source, and remember this comprehension statement with the square brackets here, is this list, this parameter list. Now that's quite a sophisticated statement and initially requires a little bit of patience to decode it carefully. So let's just be clear, we kind of get what we're talking about here. And when we actually put an example in, it should be really straightforward. There's the function name, that's the parameter. This list comprehension statement defines, using the guard on this side, the source, which is going to be the parameter, and it is going to also give us the ij pair of individual values from inside the tuple. And what we're doing is we're adding, for this list, each of the tuples together. Okay, so that in itself is quite abstract, so let's just test it out. And perhaps when we test it out, so we're going to pass it essentially a list of tuples. So there's our list. Let's put in a few tuples, and what we're going to do is separate them each by a comma, because these are items in a list. And inside the tuple, there's my first tuple. Let's make my second one that, and make my last one that. And look what it evaluates, 3, 4, 5. So exactly what has gone on. We've very rapidly combined several concepts. The list comprehension statement from the previous example defines an operation. Using the guard, it defines a source. Now, what's noticeable is that it's not a single value, it's a whole tuple that I'm lifting from here. So for each of these patterns, for each of the tuples in this list, which is the parameter I pass in, I'm adding them together. This list comprehension will end up resulting in a integer array. So what it's essentially doing is adding together those pairs. So that's 3, that's 4, and that's 5. And that's essentially what we get here. Let's just pop some other values in there just for sake of testing. So we've got 10 and 2 is 12, 1 and 13 is 14, 4 and 1 is 5. So we have some very powerful concepts here, but the logic and the way it's constructed for anyone coming to this from imperative programming languages where you have to write mechanisms, you're not writing a mechanism, you are defining simply what needs to be evaluated and where that data is coming from, i.e. the parameter. And so this bit follows the logic of every function where you pass in your parameter and this is the result of it. So we're combining very abstract ideas, but it's moving and it allows us to do quite sophisticated things. So let's have another example, and this example will define a synonym as a tuple which has a string and an int. Okay, that's what we're going to use in this next statement. This bounces back and echoes back to something we did before. We'll create a function and we're going to define the parameter is a list of these tuples. Right, that's what the square bracket means. It's a list. Okay, and here you notice again we don't define how many. We're simply saying that pattern is what we're interested in, and the output will be a list of integers. Okay, so we are combining these concepts of lists and tuples in different ways. Let's define what this function will actually do. Its parameter will be this stmks, which is our list of tuples. Then we use a list comprehension statement, and what we're going to do is, write this correctly, and let me write this out. We are going to take out the mark from that tuple. So let's fully define it. So, and that belongs to the student marks list. So let's spell that out clearly. That's the tuple sitting inside this parameter. You can look at all the relationships. All I'm doing is creating a list of the marks. I'm not evaluating it for any other purpose. That's what's going to simply occupy it. So let's test it out over here. We'll test it out by writing the name of the function, creating a list, first tuple, second tuple, third tuple, and I'm building this up slowly. First name, and I'll put a name in there, second name inside my thing, and third name. So you can just see me building this up. We're going to have 3 names. Okay, and Ali's grade is 45, Steve's is 37, and Mary's is 78. And let's have a look at what that does. So first of all, this was my list, my parameter. Inside it, there were tuples, 3 of them. This is simply return the sequence of grades, which is what this function essentially wanted to do. Let's pick a nice variation on this. Let's see whether we can create a function to do with passing. I'm going to repeat that. We're going to pass in the student marks. The function is called pass rather than marks. And then what we're going to do is we're again going to pass in a list of tuples, which is the pairing of the student name. And we are going to not return an int, but return the name. What we're looking for is extracting the name from, from that tuple. Okay, and that tuple sits inside your parameter, but we're going to add a second condition, and that is the marks have to be greater than or equal to 40, which is the pass grade. So let's test that one out, and we'll test it. What we'll do is we'll grab the same parameter list and just put it through this function. Let's grab that list, pop that onto there. We find that Ali and Mary are the only 2 who've passed. Steve is just short of it. So you can start seeing that these are quite clever combinations. It's a very simple logical combinatorial logic. So we have this thing called a list comprehension, where we evaluate this statement by going from a source list on this side of the guard and any other condition we want to add of what we're going to select, what the conditions are of taking the values. And then on this side, we do make an evaluative statement, a calculation, or just simply return a particular value. And it gives us a much greater level of complexity without worrying about mechanisms, not worried about how we code.